Okay, so what you see right now is a code that I will use to graph sound waves and basically the interference pattern formed due to a speaker. So I have imagined a speaker as a collection of points which are evenly spaced, and in theory there should be like infinite number of points, but I mean, okay, we can't actually do that. We can't have infinite number of points in a code, because that will just, yeah, it won't be able to process it. So for this code I only have 21 points. So they go from -10 to 10 in height. By height I mean the y coordinate. And yeah, so there are 21 points and they are evenly spaced, and I'm basically just going to draw a lot of circles around these points, and we will see what the interference pattern looks like. So over here in this step, you see r equal to r plus 1. This one thing is the wavelength. So it's the wavelength of the waves that we will generate. So the crests, they will be the wave of the crest, right? The wave fronts, they are spaced. The space between them is 1 unit. Okay, so let's look at what happens for r equal to for wavelength equal to 1. Okay, so you see this is the interference pattern that we get. You can kind of see that the top and bottom, like, they are not receiving much interference at all. In fact, they are not receiving much waves at all. So almost all of the waves, they are interfering in the surrounding region, right? So the region surrounding this line of sources. Okay, so it's like a tube or something, whatever. So that means that it's almost no sound in top and bottom. So if you can get your wavelength really small, if you can find a very high frequency for a speaker, then like theoretically it should be like almost as if you don't have any sound on the top. Yeah, right. I mean, you do have sound, but that's not hearable. You can only hear above some particular intensity, so it won't be any sound over there. Okay, so let's also look at what happens as we go far away from this thing, so you will get a better idea of what I'm talking about. So let's draw maybe like 51. Okay, so maybe let's draw 50 circles around each. All right, it's coming. Yeah, that's what it looks like. So now you can clearly see what I was talking about, that the interference pattern, it's mostly in this region. It's not in the top and bottom thing. Now the problem is that because my screen is rectangular, this thing is also got elongated. I don't want that, but it happened. So you have to imagine that it's like a circle. So then this white region, it's slightly more than what we see right now. Okay, this angle will be more. Okay, so that's nice. That's for short wavelengths. Let's also see what happens for big wavelengths. So let's see for 10. First we will only deal with 5 circles. Alright, so this is what it looks like. So here the region which is not the top and bottom, I don't know what to call that. I think it's called the equatorial plane. Okay, I'm just going to call it the equatorial plane. I don't care if it's axial or whatever. Yeah, it should be the equatorial plane. The axial one is the one which is like, yeah, so right, whatever. So the thing is that region, the equatorial region, it has very defined waves. So yeah, that's why you can like hear the actual frequency, but just with a very big amplitude. Okay, but the surrounding region too, it's still getting waves, right? It's not that it's not having any wave, but it's just not that profound. It doesn't have that kind of amplitude. And you can also see that the frequency of these apparent waves in the equatorial plane, it's lower, and in fact it's almost as if that the wavelength of this kind of wave that we are getting is based on how far the actual points were for our speaker. So yeah, that makes sense. So that also kind of looks like it's having more intensity on the equatorial plane, but not really. It's just that they are more compact, so the amplitude is more. Yeah, and over there the frequency is more. Okay, so that's one thing, and that's still for a kind of a small wavelength, so it's r equal to 10. We don't want that. We want a very big wavelength, so let's put 100 over there. Okay, so I don't know, 5000, that might work. Just hope it doesn't crash. Okay, so so now you can see what I was talking about. It's almost as if it's yeah, it's equally distributed everywhere. But if you zoom in very much, you can see these lines have kind of a thickness at the bottom, and then they have some thin part for the equatorial plane, right? And that's because of the compactness and stuff over there. Okay, that's really nice. So that explains how the interference pattern of a sound wave of sound waves going from speaker works. And yeah, that's all I wanted to show. Okay, have a nice day, see you later.